So given this problem statement, S is given as it contains the element y, and y has to be in the range of this interval, that is 0 to 2 pi. And this is the equation that is given: 7 times cos y square minus 3 times sin y square minus 2 times cos 2y square, that is equal to 2. So in that case, the sum of roots of all the equations, and here it is given x square minus 2 times tan y square plus cot y square times x plus 6 times sin y square, that is equal to 0, and y will take the value from set S. Y belongs to set S. Now proceeding towards the solution part. So first of all, I will consider this equation. Now we know the identity, that is cos y can be written as 1 plus cos 2y over 2 minus 3 times sine of sin y square can be written as 1 minus cos 2y over 2, and then the remaining term can be written as it is, right? On resolving this, we'll be getting 2 plus 5 times cosine of 2y minus 2 times cos 2y squared, that is equal to 2. Now subtracting 2 on both the sides, this can be written as 5 times cos 2y minus 2 times cos 2y square, that is equal to 0. Now from this, cosine of 2y is the common factor, right? So this can be written as 5 minus 2 times cosine of 2y. Now if you can observe here, from this we can write, that is cosine of 2y will be 0, and this, that is 5 minus 2 times cos 2y, that is 0. Now if you observe this particular equation, so first of all let me solve this part, and then I'll be solving the next part. So for this one we can say that x can, sorry, here cos 2y is there, so 2y can be written in the form of odd multiple, that is 2n plus 1 over pi over 2, right? So pi over 2. So from this, clearly we can say that y will be in the form of 2n plus 1 times pi over 4, right? So the set S can be written as, so first of all the first value can be written as pi over 4, right? So pi over 4, the next one would be 3 pi over 4, the next value, this would be 5 pi over 4, and the next one will be 7 pi over 4, right? And if you observe this equation, that is 5 minus 2 times cos 2y, that is equal to 0. So from this, if I isolate this cos 2y, this can be written as, this is written as 5 over 2. Now this value has to be rejected actually. Reason being, reason is already mentioned within the problem statement. It's mentioned already in the problem statement that y has to belong to this interval, and within this interval there is no value possible for y on which substitution of this one would result in 5 over 2, that is 2.5. So cos of any real number won't generate 2.5, right, as output. So therefore this particular expression, or this value of the equation has to be rejected. Now we'll go towards the the other given equation, that is this one, right? So let me just replicate here. So if you observe this one, so according to the standard quadratic equation, so a quadratic equation of the form something like this, that is ax square minus, sorry, plus bx plus c, that is equal to 0, and definitely a cannot be 0. So from this we can say sum of roots, right? Let us say the roots are alpha and let us say beta and beta. So in that case, then we can say sum of roots, that is alpha plus beta, we know this will be negative of coefficient of x over coefficient of x square, that is a, and the product of root, that is alpha and beta, alpha times beta, that is equal to constant over coefficient of x square, right? So now I'll be using these values, and set S is something that we have already computed, that is in the listed form. So if I talk about the sum of roots, that is alpha plus beta in this particular case with respect to this equation, right? So here if you observe this equation, so let me just eliminate this from here, and here we can write, right, that is for this particular equation, here definitely a is equal to 1 and b is equal to this one, that is negative 2 times tan y square plus cot y square. So this can be written as sum of roots, that is alpha plus beta, that is equal to negative of b over a. So b is this particular value, so let me just write within parenthesis. So instead of b I'll replace with this, and a is already 1. On resolving this, this one can be written as 2 times tan y square plus cot y square, and it is very clear that y belongs to this set S, right? Okay, so if I pick up the values in appropriate form, then alpha plus beta, that is, I can say sum of roots will be equal to, so let me just write this set S over here, correct? So set S is given this. Now from S I will pick up the values one by one. So if I pick up pi over 4, this becomes 1 plus 1, 2, right? Then next 3 pi over 4, 1 plus 1, 2. So this is nothing but 2 times 2. This is the first quantity, and this is occurring 4 times actually, for pi by 4, right? Then for 3 pi by 4, then 5 pi over 4, and then for 7 pi over 4. So this finally becomes 16. So for this problem statement, the answer is integer 16. So that's the idea.